For the module on epidemiologic study designs, this is the lecture segment on case control study designs. So the key features of a case control study design are that subjects are selected on the basis of the disease or outcome status. So they become cases or controls based on the outcome. So in terms of our cause and effect question, the outcome or effect, that's how we're defining our cases and that's how we're selecting our study participants. And then past exposure status is ascertained in those cases and controls. So quoting from another textbook, it's helpful to think of any case control study as being nested, that is, conducted within a cohort. So these authors are saying that it's helpful. I'm going to say that it's really essential to think of a case control study as being nested or conducted within a cohort. And I'm going to elaborate on this a little bit more, but it just has to do with case control study. You have to carefully define your cases and controls to make valid comparisons. And the best way to correctly define your case and control groups is to think of it as being conducted within a cohort. So, in fact, I will often say that the case control study is going to have a source cohort. So what does that mean? The source cohort behind a case control study is the population that gave rise to the cases. And it's really important to define that source cohort because you have to sample your controls from the same cohort. So the validity of a case control study really relies on there being an underlying source cohort and the cases and controls being drawn from the same source cohort and drawn from that cohort in a careful and systematic manner. I'll just kind of warn you that if I give you an assignment to look at an article and to tell me what is the source cohort, you won't find that the authors of the article have actually said, our source cohort is blah, blah, blah. You as the reader need to infer that. You need to think about the imaginary cohort study behind the case control study. So if we're going to conduct a case control study, we can in fact think of the source cohort as being the same population that we talked about before. The same population that we've talked about is our population at risk for measuring disease incidence, or our baseline population that we're going to enroll in our cohort study. So if we have this cohort, the cohort exists, and then time goes by and people within the cohort have disease events. And so now you have this cohort that has gone through this experience of having exposure status at baseline and then having events. But suppose that you did not actually define this cohort at the beginning, back before any of the disease events happened. Okay, suppose you showed up now. You, the investigator, are showing up now. How would you, essentially in a case control study, you're going to try to sort of reconstruct the cohort and reconstruct the past events, but in a more efficient manner. You didn't have to be there studying them all these years, waiting for those leukemia diagnoses to happen. And you don't necessarily have to know the exposure status of everyone in your cohort. You just need to know the exposure status of your cases and your controls. So you're showing up now to do this study. So what you're going to do your case control study, you've defined your theoretical source cohort, but you haven't actually enumerated or enrolled the people as you would in a real cohort study. And then after these disease events have happened, you're going to pull out your cases based on them having had a disease event. So there they all are. There's your cases. So from the people that are left behind in your theoretical cohort, which again, you didn't enumerate or name everyone, but it's a theoretical cohort that you have some kind of a grasp on who the members of this cohort are. You are now going to randomly select controls from the same population from which your cases arose. So I'm going to use these little different colored circles. The blue circles are going to be my control selection. And now I'm going to pull those controls out to be my control population in my study. So compared to a cohort study, we did not start at the beginning with the whole population at risk and enumerate every person and determine the exposure status of every person. So the case control study can be more efficient by showing up later, pulling out the incident cases, pulling out only a random sample instead of the whole cohort, and determining as controls and determining just their exposure status instead of determining the exposure status of the whole cohort. So there is this efficiency idea with a case control study. The time spent by the investigator team may be shorter, and the number of people that they actually have to contact and consent and get information about their exposure status may be smaller. But I do like to emphasize that it starts from the same concept. It starts from your source cohort and your disease events. So we're actually determining the past exposure status of the cases and controls. So another way of thinking about a case control study is that the time is going backwards in a way. So on the right, the exposure status was present at the beginning. The disease status was present later. But the way you, the investigator, are going to do the study is you're going to select people based on disease status, disease or not disease cases, and non-disease controls. You're going to assess exposure for both of those, so you'll know those 4 categories on the right at the end. An important issue to think about for case control studies is, what do we mean by controls? So here's our 2x2 table again: incident, disease, exposure, or treatment. So if this was an experiment or randomized trial, control would mean the untreated or unexposed group. That would be the control group. In a case control study, the control group is the non-diseased group. The cases are the diseased, the controls are the non-diseased. I wish someone had made a different choice when they came up with these terms for studies, and they weren't using control to mean 2 completely different things. But you just have to keep a handle on that and understand the difference between a case control study and a cohort or experimental study, and use the word control in the context that your study is. So in a case control study, suppose we go to this graphic where, again, now each person in our theoretical source population is now a horizontal line, and they are being followed through time. So this is our source cohort, right? We've got exposed and unexposed. We've got people with disease outcomes and people without disease outcomes. But again, this time we're doing a case control study. So we didn't start at the beginning. We didn't start at time 0 with our exposure status and our full cohort. We're coming in later and we're sampling our cases. So the cases are obvious. Everyone with the blue circle is going to be a case. And then we're going to just sample some controls from the population. So how are we going to do that? So one way of doing that is what's sometimes referred to as risk set sampling. For every case that occurs, we're going to select one control from the risk set, the set of individuals who are at risk and members of the study of the source cohort at the time that that case was diagnosed. So the first case is diagnosed at the very top after a very short time in the population at risk. So we need to sample one control who is in the cohort at the time that happened. So there's the case being sampled, and now here's a control being randomly sampled, so that person's horizontal line indicates that person is being sampled. Okay, now 2 more cases happen soon, so they are selected as cases. And then from the risk set, the people who are still at risk at the time that those happen, we're selecting more controls. So each time a case happens, they are selected, and then for each case, we are selecting a control from the risk set. Case, control, case, control, case, control. So the point of this graphic for case control studies is to think about the fact that by the time that those cases happen out towards the end of the period of observation, those later occurring cases, you could only select the controls that were actually still in the population at the time that those cases happened, at least in the concept of risk set sampling. And for certain types of exposures and diseases, this is a very important part of the sampling procedure. Okay, another graphic illustrating how a case control study has to arise out of a cohort study. And this comes from the Rothman textbook. So at the upper left, the black and white dots are the source population. Each circle is a person, open circle is exposed, blacked-in circle is unexposed. So that's the whole population. And if you're going to do a cohort study, you would follow that population and see who becomes a case. And so all the little squares on the right at the top are the cases drawn out of that population, and their exposure status is shown there. So that would be one way of studying this disease outcome in this exposed and unexposed population. Another way of studying the same population would be to do the case control study. So we would select all the cases just as we did for the cohort study. But then instead of studying the entire population, the big square of black and white dots, the entire source population, instead of studying them, what if we just took a random sample and made them our control group, and then we would compare our cases and controls? So this shows you that a key thing about case control studies is that there was a certain pattern, right, of black and white, of exposed and unexposed in the source population. Your control group has to represent the same distribution of exposed and unexposed as your source population. You have to sample in a true random fashion in order to achieve this, because the concept of your case control study is to compare the exposure experience of your cases to the exposure experience of your controls. So your controls must represent the entire underlying source population. So looking at this example, is disease related to exposure in this example? Well, looking at either the source cohort or the control group, it looks like about 1 out of 4 study subjects is exposed, right? Three unexposed blacks to 1 white exposed. When we look over at the cases, it looks like it's almost 50-50. There's just about 1, okay, just a little bit different from that, but pretty close to 1 white for every 1 black, which is on its surface pretty different from the pattern. The proportion of black and white in the controls, the proportion of black and white in the cases do seem different, or the proportion of black and white in the source population, the proportion of black and white in the incident cases arising from the cohort, those do seem different. So the cohort study and the case control study are both relying on this concept that we're going to compare our exposure status in the incident disease group to those who do not have disease. So exposure odds are 1 to 3 in the control sample. Exposure odds are 1 to 1 in the case sample. So those are some different odds. Okay, so the data layout for a case control study, we can use this 2x2 table, and it looks very much like the randomized trial or the cohort study. We still have the same 4 possible categories. We have exposed or treated yes, exposed or treated no, outcome yes, outcome no. The difference being that in a case control study, we don't actually know the true incidence of disease. Remember that in a cohort or a randomized trial, we can go across the table and look at the exposed category or the unexposed category and know the number of incident cases compared to the population at risk. We don't know that in a case control study because we do not have the full cohort. We only have that random sample. So we can't know the incidence of disease, but we can still compare the odds of exposure in the diseased and the odds of exposure in the non-diseased. And again, the lecture on measures of association will come back to those quantitative issues. So why use a case control design? It can be efficient for rare diseases. If you are trying to study a rare disease and enrolling a very large population into a cohort and waiting for those rare events to happen, it's going to take a lot of personnel effort, and it's just going to take a long time. And so in terms of getting your career moving forward and having some data, a case control design can be more effective. A case control design can actually permit the study of multiple exposures as potential causes of the same disease. So we talked about randomized trials and cohort studies and looking at multiple outcomes for the same exposure. Case control study, you can look at multiple exposures as risk factors for the same outcome. And a case control study may be quicker, easier, and less expensive than a cohort design. I said usually in the slide, but believe me, a well-conducted case control study is going to take a fair amount of resources as well. So speaking of the advantage of a case control study for a rare disease, a rare outcome, this is a real example of some data that I had the opportunity to analyze. It was actually a case control study that Marty Slattery had initiated of breast cancer cases and controls, over 2,000 cases, over 2,000 controls. For breast cancer studies, there's always a lot of information collected about any use of exogenous hormones, which includes contraceptive hormones. And so it happened that the individuals were asked whether they had ever had the contraceptive implants, the implants containing hormones used as a method of contraception. Out of that entire study population of nearly 5,000 people, there were only 17 that had ever used that method. The odds ratio became very strong and significant, but we're drawing a conclusion based on only 17 exposed people. So relative rarity of breast cancer in the community was overcome by doing a case control study, but the exposure was highly rare, and in this community-based study, we had so few. So contrast this with a study that I found to refer to in our discussion section, a study that looked at invasive breast cancer by initial use of Norplant IUD or sterilization. This was a post-marketing surveillance study, so essentially this was a cohort study. So they actually accumulated, so Norplant being the hormonal implant, they accumulated almost 40,000 person years of use of this contraceptive. However, these are very young women who were using these contraceptives in this study, and so they weren't old enough to have breast cancer. There were only 4 breast cancer events observed during the 40,000 person years. So trying to study the same question, whether breast cancer incidence was related to this type of use of this hormonal contraceptive, the first study, the case control study, was limited by the rarity of the exposure. The cohort study was limited by the rarity of the outcome. So that's just a real-life example that I've come across in my career, that the 2 different study designs have advantages and different disadvantages for rare exposures or rare outcomes. If you're trying to deal with a situation where both the exposure and the outcome are rare, it can be very challenging. All right, so problems with case control designs. One is that the exposure may be difficult to assess retrospectively. A really key aspect of a case control design is you're studying people after their case, or you're going to the controls and trying to determine their past exposure. The fact that someone is now a case may change their behavior. So we had the example with the studies of cigarette smoking and lung cancer, where the argument was made that the cases probably smoked more after they were starting to get lung cancer because smoking made them feel better. It was so soothing to the lungs. So that's an example of where they were saying, well, the assessment was not of the true exposure status before the disease, you are assessing the exposure status after the disease. So that's kind of a one example, but there's just many, many examples of where you can find your cases and controls, but what you really want to know is what was going on with them, in some cases years ago, before that disease status happened. And that may be very difficult to find out. When people are trying to determine, the associations between diet, eating habits, and disease. Getting people to tell you what they eat now is hard enough. Asking them what they used to eat years ago, pretty difficult. And a number of other exposures can be difficult to find. Second problem with the case control designs is that compared to a randomized trial in a cohort, we do have less confidence that the exposure actually preceded the disease. And finally, sampling cases and controls can be tricky and may introduce bias. And this is something that we'll go into more in the fall epidemiology class if you're going to also take that intermediate epidemiology. But for the moment, just think about the logic of that. If you have the entire cohort, and then within that cohort you've got your cases arising, that gives you a lot more confidence that you've got the appropriate comparison groups, as opposed to sampling cases and controls from this theoretical source cohort that you don't absolutely know all the members of, or how to contact them, or how to recruit them into your study. So again, the biases that may affect a case control study would be information bias. That is to say that the ability to determine past exposures may be affected by present disease status. And case control studies can also be affected by selection bias. Cases or controls sampled for the study may have a different distribution of exposures than cases or controls in the true source cohort. So these 2 opportunities for bias often mean that cohort studies are considered superior to case control studies in terms of ability to infer cause and effect that isn't influenced by bias. However, my message to you is not to refrain from conducting a case control study, as we're going to talk about more this semester and in the fall intermediate epidemiology course. Having a carefully designed and well carried out case control study, you can reduce the opportunity for these biases.